Today's automobiles are traveling electronic devices, running computers. Sensors, ECUs, actuators, and other control systems are increasing in complexity and sophistication at an accelerated rate. For this reason, the wire harness linking these together has now grown to a total length of 3 kilometers and weighs 50 kilograms. As automobiles become increasingly electrified and intelligent, the question becomes, do we need a completely new development environment to respond to the next generation EE design?
For example, the development of lane-keeping control extended to the design of various functions, including the ECU, cameras, software, and steering. When adopting a conventional style of development, of exchanging specification sheets between processes and functions, it becomes harder to communicate changes and easier to make mistakes due to details as to how each process and function relates to one another becoming unclear.
To resolve this issue, we at Zuken propose innovative solutions which incorporate a software development mindset into automotive EE design. One such solution is Architecture Planner.
Architecture Planner makes it possible to define functions, parts, networks, and other functional architectures into a unified database. Even the vast amounts of electronic component information provided by component suppliers can be imported into Architecture Planner's unified database in a variety of formats, making starting a new architecture design easy. Multiple engineers with knowledge on various design domains can also simultaneously develop together, while referencing information provided by other developers. This makes it possible to define a functional architecture with consistency based on the latest information. And physical architectures can be designed under a variety of conditions, using such functional architectures as a basis. Of course, even without functional architecture present, users can gather past detailed design data and the like to design a physical architecture. By visually comparing the wire harness costs under separate conditions, and the weight, robustness, and so forth, users can quickly determine the optimal physical architecture to use while considering variations. Wire harness product specifications will be generated automatically from the optimized physical architecture. With this, these specifications are then passed over to production design. All information up to this point is configured based on inheritance technique. This makes it possible to easily detect influenced areas of engineering change and quickly reflecting the necessary modification from a functional architecture to production of ECU and wire harnesses. Searching for these influenced areas does not require a massive amount of time, allowing developers to concentrate on better EE design. Information can also be used globally on varying platforms. Users can apply the latest information across platforms.
Conventional development environments cannot keep up with the increased evolution and complexity of the automobiles of tomorrow. Change propagation based on inheritance technique, cross-platform level design, global distributed and cooperative design. Zuken is taking automotive EE design forward into the future with a new vision.